Are you ready to push the limits of science and dive deep underground? If you haven't watched the first part of this two-part series, click the video above to learn how we built the futuristic ship that will take us on our journey to the center of the Earth. Let's imagine we're scientists who have just penetrated the Earth's crust and are about to go where no one has gone before. As we look out the windows, we see a strange and hidden world below the surface. We first pass through a layer of sedimentary rocks comprised of various minerals and sediment compacted over millions of years. Depending on the mineral composition, the sedimentary layer may appear in shades of brown, red, and yellow. As we travel through the crust, we encounter unexpected geological formations and pockets of gas that hiss and bubble, creating an eerie atmosphere. The light from the ship casts shimmering reflections and long shadows that disappear into the darkness below us. After some time, the ship emerges into an open underground cavern that shimmers with a warm glow and is filled with glittering minerals. Stalactites and stalagmites, made of calcium carbonate, reach up from the floor and dangle from the ceiling, like frozen waterfalls. We continue, and with each mile, the pressure and temperature increase. Soon, we come across an underground river that winds through another large cave. Did you know that running water is an excellent tool for transforming landscapes? With enough time, we're talking thousands or millions of years. A simple stream has the power to shape hardened rock. As we follow the river, it narrows, and the walls close around us until we emerge into another cavern, filled with towering columns of crystal-clear quartz. Crystal-clear quartz is a mineral known for its transparent, colorless appearance. Its clarity is similar to a flawless diamond, which allows light to pass through without distortion or opacity. The mineral comprises tiny crystals, arranged in a precise and symmetrical pattern, giving it a distinct geometric shape. The view is breathtaking, like being in a gigantic jeweler's shop surrounded by thousands of diamonds. The crust isn't too deep compared with the other deeper layers, and as we descend, we begin to notice the walls become smoother and the temperature spike dramatically. Finally, we have reached the next layer, the mantle. As we burst through, we see that it's made up of a complex mix of different rock types. The mantle is a crucial component of the Earth's interior, making up most of its total volume. This is a fairly active area, and we can see how the immense pressure causes the rock to deform and fold, creating massive upwellings and downwellings that influence the Earth's surface. We will be traveling for quite a while because this layer is about 1,800 miles deep. As we drift deeper into the mantle, the rock becomes increasingly dense and flows like a slow-moving liquid. This region is in a constant state of motion, and these flows play a critical role in the Earth's tectonic processes. The movement is called mantle convection. Without it, the Earth's surface would be much different, with no volcanic activity, earthquakes, or new land formation. Massive plumes of partially melted rock rise from deep within the Earth, powered by heat from the core and intense pressure from the overlying layers. These plumes can cause the formation of hotspots on the Earth's surface. People will see volcanic activity at the surface as magma rises from the mantle and comes out of volcanoes to form new rock. This is how new islands, such as the Hawaiian Islands, are created in the ocean. We also see more evidence of mantle convection as we watch hot rock rise from the abyss and cooler rock sink. This drives tectonic plates and the creation of new land. At this depth, temperatures get hotter and begin reaching 7,200 degrees Fahrenheit. The mantle is a valuable source of minerals and other resources, including diamonds, formed from carbon-rich material carried up to the Earth's crust by volcanic eruptions. Let's continue our quest and push the ship deeper. We're now entering the outer core, and as we look out, we're amazed at the sudden change in surroundings. In front of us is a strange and alien environment, unlike anything we've seen before. This region, estimated to be about 1,300 miles thick, is a seething ocean of liquid iron and nickel that swirls before us, churning with tremendous energy. This region is primarily liquid. However, things will change once we reach the inner core. The outer core is also responsible for generating the Earth's magnetic field, which is crucial for protecting our planet from dangerous solar radiation. We begin to notice strange electrical discharges form and dance across the surface of our ship. These discharges are part of the outer core dynamo theory, which explains how the Earth's magnetic field is created. As the molten iron in the outer core moves around, it generates a powerful magnetic field that extends outward and surrounds the planet. This magnetic field plays a crucial role in protecting our planet from the harsh environment of space. Without it, the solar wind, a stream of highly charged particles from the sun, would strip away our atmosphere and make life on Earth impossible. Imagine looking out the ship's windows at the eerie glow from the molten iron and nickel. The bright orange light illuminates the darkness, casting strange shadows on the ship's walls. The intense heat and pressure are perilous and could destroy our vessel at any time. Yet despite the risks, as scientists, we're drawn to the unknown and the excitement of discovering something no human has ever seen. We experience massive turbulence caused by the movement of liquid metal around us. This layer of Earth, along with the resulting magnetic field, is astonishing. The iron and nickel react to intense pressure, creating explosive bursts and streams of liquid metal. We quickly leave this area, and as our ship moves into the inner core, we brace ourselves for what lies ahead. The inner core is the very heart of the Earth, a solid ball of iron and nickel nearly as hot as the sun's surface. The inner core is approximately 730 miles in diameter, and the scorching heat is higher than the outer core, with temperatures estimated to be around 9,000 degrees Fahrenheit. With such heat, you may wonder why the inner core is solid and not melted liquid. The reason is that because we are so far inside the planet, there is an estimated 3 million times more atmospheric pressure than at the surface. The pressure and density are too great for the iron atoms to move into a liquid state. Thus, they perpetually remain in a solid state even at these temperatures. The inner core contributes to the overall structure of the Earth. It also works with the motion of the liquid iron within the outer core to generate the Earth's magnetic field. The Earth's core is one of the least understood parts of the planet, and much of what we know about it is based on indirect observations and simulations. As we pass through the inner core, we're astounded by the strange and mysterious environment. The walls of the ship creak and groan under immense pressure, and the air is filled with a haunting metallic hum. We're exhausted but exhilarated after our long journey through the depths of the Earth. Then, finally, we look out the ship's windows and see the once fiery landscape of the inner core receding behind us. The journey back up would be just as challenging as the journey down, since the ship would have to navigate through the tectonic plates and earthquakes that make up the layers closer to the Earth's surface. After hours of traveling, we finally break through the crust and emerge into the sunlight on the other side of the planet. If you remember, we started our journey in New York City and drilled straight through the Earth. The antipode of New York is located in the Indian Ocean, near the southern tip of Madagascar. Looking around, we can see the vast expanse of the ocean stretching out in every direction. Above us, the sky is a brilliant shade of blue, with a few wispy clouds drifting by. What a journey. Maybe we could consider a simple plane ride the next time. You've seen what's inside our planet, but don't know what could be far out in space. So join me in the next video as we explore the far reaches of space and search for aliens.